Heh, now this is a slot 1 build off. Hey all, welcome back to another episode of Retro Tech Bites. This is Will, and yeah, today is the first day of the slot 1 build off. So yeah, little about slot 1 build off. It's exactly what it sounds like. And what you're looking at, this is my soon-to-be slot 1 machine. So let's talk a little bit about the parts and just a little bit about what this whole thing's about and why I'm doing what I'm doing. So for that latter question of what this is all about, well, Uncle Mike's Retro and OCR, they kind of do their back and forth thing. Well, they reached out to me and SUCRA, or Bruno as some of you know him, and asked us to join in a slot 1 build off. So behold, slot 1. Building off. Alright, now that that's out of the way, let's talk a little about part selection for this thing. So I wanted to go a little unconventional, and by a little unconventional, I mean very, very unconventional. For the more conventional half, we have two of these. Well, they're mismatched, but Creative and G111 Voodoo 2s by 3DFX. These are 12 megabyte cards. This one dates to, looks like 1998. Not much to say. I mean, if you know about Voodoo 2s, you know that they're kick-ass. They are, capable of SLI. That's exactly what we're going to be doing. And for 12 megabyte cards, they're obscenely fast. I mean, they are some of the best 3D cards. But for those of you not familiar, the gist of it is you can have two of them, like with more modern cards, in SLI. And the other big thing is they have pass-throughs. So these are not 2D cards. There's no 2D hardware on here at all. These are all 3D, and so you pass your 2D card through this, and out comes the 3D 2D mixed signal. And it'll switch between your 2D card and 3D card depending on if you're playing glide games or whatever. Speaking of 2D cards, we have this. Yep, we're using an ISA card, but this is not your average Tseng Labs ET4000. This is an ET4000 W32i. It's not in the best physical condition, but it works great. This card was made in the US by Microlabs, and as someone pointed out on Twitter, yep, on a Korean-made chip, a Made in USA sticker. Love it. But these cards have 45 nanosecond RAM, and the big draw is they have 2 megabytes of RAM. And what happens is, because this is the I variant, it has Windows hardware acceleration built into it, and it interleaves these banks of RAM, effectively turning 32-bit memory access into close to, or approximating, 64-bit access. It's a gorgeous card, a little bit beat up as you can see by the bracket here, but nonetheless, it's a fantastic card, and it is just so fast. It is probably one of the fastest ISA cards in Windows generally, and it's a joy to use, an absolute treat. So I figured, you know what, why not? It is close to a VLB card in speed, and VLB is like kind of sort of ish close to slow PCI, so by the transitive property of slowness, this is like a very, very slow PCI card. Maybe, possibly, we'll see, but it's going to be interesting nonetheless, and it should be more than enough to accelerate some Windows, that's for sure. Ah yes, sound options. Well, yep, you probably all noticed the red PCB by now, but this is a Gravis ACE. Not much to be said other than this is a Gravis UltraSound that goes alongside your existing sound cards. It does not use the ad-lib port. It sounds amazing, it looks amazing, it's a Gus. I mean, everything's been said about Gus's that can be said, but yep, it's a Gus. This is that Magic S23A card. This has a, well, kind of ish, stolen-ish, reverse-engineered copy of the Roland Sound Canvas on it with a Crystal CS4236. This will take care of Windows sounds and Sound Blaster compatibility. It has an OPL3 clone. We're not going to get real OPL3, but for Windows games, who cares? This is just if I want to play some DOS games or listen to some MIDI files, gives us some flexibility. And last but not least, what is probably one of my favorite PCI sound cards and one of the least talked about. I know Phil from Phil's Computer Lab loves this card. This is not just your average crystal card, but this is the Turtle Peach Santa Cruz. It's it's a monster. It's a top-of-the-line PCI card capable of, through HTRF emulation, processing both A3D and EAX sounds, and it does so really well. Probably the closest implementation to both that a card compatible with both can be. It has 2 code Cs on it, and yeah, it's got this Versa jack, which is pretty nice if you want to do any SPDIF or anything like that. Yep, it's got a wavetable header, so technically I could add even more MIDI to this monster if I wanted to. But the unfortunate thing is this does not expose the MPU 401 to DOS, so consider this a Windows-only card. And that's exactly what it's going to be. For games with A3D sound or EAX sound, it gives you the best of both worlds. Well, this is a slot 1 build after all, so the CPU has to fit on a slot. This is a Pentium 3. It is a 600E with 256 kilobytes of level 2 cache, 100 MHz frontside bus, and it runs at 1.65 volts on the V-core. It's a Coppermine model, pretty fast. It's the fastest I've got. Unfortunately, the rest of mine are Coppermines, which are basically souped up Pentium 2s, or I could have put a Pentium 2 in here, but, you know, I figured why not? Let's go all out. So, Pentium 3 600. And then there's this, which also is weird. An Olidata branded Oli-ZX motherboard. This is actually not some sort of proprietary board, as you've probably guessed already by that ASUS chip. It does have an Intel ZX chipset, so it's basically a cut-down BX board, but it's got the full speed and features of the average BX board, and while it's limited to 512 megabytes of RAM, you know, it's a pretty solidly built board. That being said, there's more to this than meets the eye. Since it's an ASUS built board, this actually is a clone of the ASUS P2Z. Like literally, 1 for 1, this is a clone. Except it's green, which is pretty cool. I happen to like green PCBs. So this board, as a matter of fact, can run the P2Z's BIOS. And on here is the latest P2Z BIOS, because you know what? Why not? Let's do it. So yeah, these are the parts, this is the build, and let's get this together and get some testing going. Alright, so let's get the show on the road. I'll probably speed up some of this footage as we go along, but yeah, general idea is just getting this thing together and then getting Windows on it and going from there. And there we have it. While it's a modest build and it's not going to win really any awards for cable management, although you could say that is accurate to the era since cable management didn't really exist back then. Yeah, it's a competent selection of parts, and you know, it fits in a relatively modern ATX chassis like there's no problem. This tired old Thermaltake Commander is one of the few free chassis I have while I'm, you know, currently in the middle of a office renovation here. So I figured let's just put it to use because it's kind of just been begging to have parts put into it. I know the power supply is new, but vintage power supplies really need to be recapped now and again, and it's not worth going through that right now. And you know, overall it looks pretty solid. Pretty much every port is in use that can be in use except for AGP, of course, because we're going ISA. And otherwise, you know, the build itself was pretty clean and simple, and I'd say it was one of the easier ones I've built. So let's get it powered up, let's install Windows, and let's see how this goes. Well, that's pretty loud, and it's kind of interesting how the post screen like sort of loads in like some sort of sci-fi 1980s computer terminal, but it's alive. So let's get it configured and get moving. But it looks like everything is okay. Apologies about the loud fan. It's a 2000 RPM fan. And yeah, it's definitely running at 2000 RPM. But let's decrease that just a little bit and see. Maybe we can up the speed of the Tseng a little bit. Yeah, let's see. Can't even detect the speed, which makes sense. Otherwise, everything else looks good. All right, let's switch to direct capture, get this thing set up, and see how it runs. Alright, as far as the install went, it was a fairly standard procedure, nothing special. The one thing that surprised me was Windows 98 was able to detect every single card in this computer without some sort of resource conflict. When's the last time you saw that? Hell, as crazy as it is, the fact is it worked. Every single card was detected, and less complicated machines often don't have that luxury. The only thing that really didn't show up here was the GUS, but that's to be expected as it's a non-plug-and-play device, so it would just be manually added later. But otherwise, everything was there, and it showed up in Device Manager as it should have. Next up, everyone's favorite task, installing drivers. And yeah, as far as things went, the driver install was pretty simplistic. For the most part, it was just a matter of installing the Windows chipset drivers for the Intel chipset, installing the Windows drivers for the Tseng ET4000, then realizing that the actual Windows drivers that were included are better, adjusting the resolution, installing the drivers for the various sound devices, of which the Crystal Audio Code C was already in there, so the only thing that had to be added was the Turtle Beach Santa Cruz, and that was easy, and installing the drivers for the Voodoo 2s. I initially went with the fast Voodoo drivers, but later reverted to the more basic drivers. The thing with the GUS install is you just have to install it in DOS first and then in Windows, but yeah. So as it turns out, my earlier snarky remarks in the comments and captions there regarding the Gravis Windows 9X drivers are true. The Windows 9X drivers for the Gravis GF1 chip are very immature. They cause issues because they treat the system like it's running DOS, and they set the path to C:\ultrasound, which doesn't allow Windows to load because Windows is located in the Windows directory. So instead, you gotta boot into Windows, you gotta change things around, and of course the system still hangs. After multiple attempts, I was finally able to get it going, but the fact is I was not able to get MIDI sound within Windows. But I could get DOS game MIDI sound working just fine even in Windows DOS boxes, with the ultrasound. So overall it was a success, but a partial failure? I wouldn't recommend a GUS in Windows 9X to anyone. But you know what I would recommend? Games. Let's play some games. First up, one of my favorites, and a perennial favorite, AoE 2. This game runs in software rendering, which means it's using the ET4000 W32. It actually runs in basically real time, so yeah, we're running AoE 2 on an ISA card, at 800 by 600, mind you. So yeah, let's take a listen, and here's the soothing sounds of AoE 2. Dang, almost lost myself there. I love that game. But yeah, let's take a look at something else. Here's StarCraft also running on the Tseng card. At 800 by 600, the card does really well for running on an antiquated 8 MHz bus with, minimal frills to it. It's a very powerful card, but it's definitely being held back by the bus. Overall though, I'd say it's more than adequate for the experience. So yeah, let's enjoy some StarCraft on an ISA graphics card.
Additional supply depots required.
Commander. Let's move. Permission to speak freely, sir. I'm not sure you know what you're doing. If you're going to send us into hostile territory and you want us to defend ourselves, then use the attack command. But if you want us to ignore enemy fire and go exactly to the spot you targeted, then use the move command. Now, which'll it be?
In order to equip additional personnel, you must have enough supply depots to support them. You can use SCVs to build additional supply depots.
I read you. Commander, let's move. Outstanding.
Let's do something we haven't done in a while. Here's a side-by-side of Quake 2 running on the ET4000 at 800 by 600 and on the Voodoo 2 in SLI at 1024 by 768. You can notice that the Voodoo 2s on the right obviously just look much sharper. The fact is, there's something about the charm and color of the blocky pixels of software rendering, but the Tseng card on the slow and lowly ISA bus just isn't cutting it. It would probably be playable if we dropped the resolution, which is impressive nonetheless, but again, I wouldn't recommend it. And why suffer through that? We have two Voodoo 2s after all. And the fact is, when you do drop the resolution, the Tseng card's pretty impressive. It's able to run the game at 320 by 240 with a highly respectable frame rate. The fact is, it's a decent card, but not recommended for this type of gaming. And 23.1 ain't bad for an antiquated, lowly ISA graphics card, that's for sure. But we're not here to run Quake 2 on software rendering on the ET4000 and call it a day. No. We're here to play games like Half-Life. So here's Half-Life 1 running on the Voodoo 2s and SLI. It's at 1024 by 768, and the FPS is somewhere between 50 and 72. It pretty much stays locked at 72 for the most part, but occasionally dips down into the 50s when big action scenes come. The fact is, the system is just built for games like this. It's not built to run games with that lowly, old, antiquated card. But in games like this, it shines. It really, really does.
Bring it on! Okay, why not? Didn't want to die alone anyway. Got another one.
But say you wanted to run some DOS games. Yep, we've got a Gus, we've got a Tseng card, so let's run Doom. and it runs perfect, as is to be expected on a 600 MHz Coppermine Pentium 3, but again, we have a bottleneck in the ISA graphics card, so nonetheless, this is pretty impressive. Plus, here's that kick-ass Gravis soundtrack. I'm not gonna lie to you, this one surprised me a little bit, and I think it was something to do with not using VISA modes properly. The Tseng ET4000 is weird with its VISA implementation, and that really shows in games like Duke Nukem 3D, where at 640 by 480 we're getting 10 FPS. That's unacceptable on a system of this caliber, and I mean look, the game is totally playable, but the card is entirely the bottleneck. Comparing that to other games like StarCraft and AoE 2, where the card ran them fine, yeah, there's probably some settings and things to be tweaked, but again, the fact is, it just didn't run that great for me. Would I recommend an ISA card for this? No. I would recommend running a proper PCI graphics card on a system like this, or AGP, mind you. And that really brings us to the end of this. So let's run 3D Mark 99, which clearly does not like the Tseng card, and we'll get a whole selection of neat things, from the pod race game to the first-person shooter that's totally cool and should have been released but never was, to rotating textures, to the waving textures that look like a knockoff Windows logo. Yeah, after a whole slew and battery of tests, that leads us here. The final result: 9,391 CPU 3D marks and 5,306 3D marks for the two Voodoos at 800 by 600. This is an impressive result, and frankly, we could probably go a little faster with a better CPU, but this is my slot 1 build, and this was slot 1 build off. I hope you guys enjoyed, and thank you very much for watching. Feel free to like and subscribe to the channel if you want to see more of this content, and hey, I don't know if you've seen it, but if you haven't, go check out one of my other build videos. I built a couple of 486s, a 386 technically, that masqueraded as a 486, and yeah, I'll see you around.